And welcome back, and it's the 4th of March, 5 a day for the higher plus, and let's just jump in with the first question. Actually, this one doesn't look too bad, does it? So this is just an expansion using surds. So we've got a quadratic, so I'm going to do the usual, multiply everything by everything. So 3 times 10 is going to be 3 root 10. 3 times root 3 is going to be 3 root 3. Then I'm going to use root 2. So root 2 times root 10 is root 20, because I multiply the numbers inside the roots. And root 2 times 3 is root 6. Now, with these questions, there's two stages. One is the expansion, and the next stage is working out if you can simplify any of these. And I know already, so there's a bit of experience coming through. This is the same as root 4 times root 5. The square root of 4 is 2, so this is just 2 root 5. In other words, to be clear, my final answer is going to be 3 root 10 plus 3 root 3 plus 2 root 5 from the root 20 plus root 6. And I can't combine any of those any further, so that's my final answer. Next question. Okay, so the next question looks like two functions and we want to solve. Okay, it's a good question. Right, first thing I'm going to need to do is I'm going to need to work out what the inverse. So this means the inverse of f of x. So what does f of x do? So f of x adds 1. So the first thing it does is add 1, and then it divides by 3. So my inverse function is going to do the opposite. So my inverse function is going to multiply by 3, so 3x, and then it's going to take away 1. So my inverse function is, or f minus 1 of x is 3x minus 1. And then from the question, I know that 3x minus 1 is equal to 8x plus 9. And I just have a linear equation, one unknown, one equation, and so I can solve that. So take away 3x on both sides, gives me 5x. Take away 9 from both sides, gives me minus 10. And that implies that x is equal to minus 2. Not an easy question, but definitely not as bad as it looks, as long as you know how to do the individual stages. Okay, so next up, so we've got a Venn diagram, and it looks like some probabilities. So I'm not sure if I'm going to need these numbers, and actually I wouldn't normally work out numbers I don't need, but just so I can say it out loud. So there's 14 plus 9 plus 4 plus 2, so therefore that means there is 20, there's 29 cars overall. So that's just interesting to know. And then in here, well, it's going to be 15 because it's going to be 29 minus 14, but let's add them up. So 9 and 4 is 13 plus 2 is 15. So there's 15 inside and there's 14 that are neither A or S. Okay, just good to know. Let's read the question. A car is chosen at random. The car does not have a spoiler. Find the probability the car has alloys. Okay, so I've picked a car and it's telling me it does not have a spoiler. So therefore the car does not have a spoiler. So therefore it's going to be one of these cars here because it does not have a spoiler. So that's 23 cars. And then it's saying find the probability the car does have alloys. So it's going to be one of these 9 cars that also doesn't have a spoiler. So therefore it's 9 out of 23. Okay, I'm happy with that. The reason, just to explain a little bit, because I think it's useful to hear it. A car is chosen at random usually means that I'm picking from all the cars. But then this sentence here implies that it is given that my car is from the 23 that does not have a spoiler. So actually that does read okay. It's just the way that I read it to start with. I'm happy with that. That's okay. 9 out of 23. Next one. Right. Find the probability of this thing here. Now it's always easier to say this in words rather than trying to work out what all the symbols mean. So if I say it out loud, it says find the probability that I choose a car. So in this case, it is out of the 29 cars available. And find the probability that the car I choose, now, again, let's read this carefully. So has alloys or has a spoiler, but is not one of those. So in other words, doesn't have an alloy, doesn't have spoiler, or doesn't have alloys, and doesn't have a spoiler. So it must be one of these 14 cars here. So it's going to be 14 out of 29. Again, difficult question, difficult to explain. It's more difficult to explain on a YouTube clip, but hopefully you got the idea of where that was going. Next question and final question today. Prove the angle at the centre is twice the angle at the circumference. Now, if you've been watching my videos along the way, you will have seen me do this one already. And if you watch my other videos with proofs, I'm going to talk to rather than write down all the words here, because otherwise you'll just watch me write words for a long period of time. These proofs, any circle theorem proof, are kind of the same idea each time, which is from the centre, you're going to create a radius like this. And that means you have an equilateral triangle on the left and an equilateral triangle on the right. Now, this diagram is slightly misleading because this diagram kind of implies that these two angles here are equal. But I don't think you can say that without it absolutely being explicitly said in the question. So what I'm going to do is I'm going to say that this here is angle Y, and I'm going to say that this here is angle X. Now, if that's angle Y there, then because this is an isosceles triangle, this must also be angle Y, and these are the words you need because base angles of an isosceles triangle are equal. So you'll be writing down base angles at the right time. So base angles of an isosceles triangle are equal. So you need to say those words. Now, equally, if I look at the X value, because this is also isosceles, that means that this one must be X as well. Now, because angles in a triangle, so again, listen to the words I'm saying, because angles in a triangle total 180, it means that this here is going to be 180 minus 2x, and it means that this one here is going to be 180 minus 2y. And then this is a clever bit that clinches at the end, which means that this angle here is going to be 360 minus 180 minus 2x minus 180 minus 2y, which is, now 360 minus 180 goes away, so that just leaves minus 2x, which is plus 2x, minus 2y, which is plus 2y, which is 2 times x plus y, which is the angle at the outside. Now again, if you are proving this in an exam, which I don't think you will have to, by the way, because it's just quite a difficult proof and it's not really on the requirement that you're supposed to know, but you'll be writing down your words along the way. So angles in a triangle total 180, angles around a point total 360, etc., to make sure we're explaining it clearly. But either way, good question, a sort of a nice sort of understanding question, although I don't think hopefully you would ever see that question. That adds to a nice mix today, kind of fairly quick today, not too bad. Let me know how you did, and I'll see you for tomorrow. Thanks all.